Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel tanmoyChem. Today's topic of discussion is one MCQ. The question is in front of you. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. Don't worry, after some time you will get the right answer. I believe you have tried, so let's start. So question, which of the chloro derivative reacts efficiently for both SN1 and SN2 with aqueous KOH to produce alcohol? Four options. By the way, it looked quite awkward that one substance will be effective for both SN1 and SN2. It's not normal. It's not common. It's a special example. And with KOH means here hydroxyl ion is acting as the nucleophile, and obviously the product is actually alcohol. So this question is actually alkyl chloride to alcohol preparation. Now here, let's learn little bit about basic of SN1 SN2. If I say primary chloride, secondary chloride and tertiary chloride, so if you go from primary to tertiary this direction, SN1 increases. If you, because this carbocation produced in SN1 reaction in the first step, that is more stabilized. Tertiary carbocation is more stable than secondary than primary. Similarly, if you think from SN2 perspective, so from tertiary to primary, if you migrate, SN2 increases because primary case bulkness is minimum. So SN2 is influenced by the bulkness. So now, as I told, SN1 primary chloride. So this primary chloride, it is actually SN2, it is better. If you look at this tertiary chloride, it is obviously SN1 better. If you look at phenyl cation, this phenyl cation cannot participate in neither SN1 nor SN2. Why? Because if it undergo SN1, it produces this phenyl cation. The positive charge is in the sp2 hybridized orbital, student. Do not get confused with benzylic. Benzylic cations are resonance stabilized. They are in conjugation with this benzene ring. Whereas this phenyl cation or this positive charge is in sp2 orbital. Positive charge means obviously deficiency of electron, no electron there. So it is very unstable. So SN1 not possible. Now if you look at SN2, then nucleophile need to attack from the backside. So if the nucleophile try to approach from the backside, it cannot be successful. Why? Because the pi electron density of this benzene nucleus repels the electron rich nucleophile molecule. So both SN1 and SN2 not possible. By the way, there is another term, partial double bond character of this carbon chlorine bond because of delocalization of electron density of chlorine inside this ring. That's another issue. I am not going. So in conclusion, these phenyl chloride or chlorobenzene cannot participate in both SN1 or SN2. Now, so now question remains, that's our option C. Actually it is the answer because all three options are not possible. So only now question, why these allyl chloride? It has a name, if possible remember. Allyl chloride is efficient for both SN1 and SN2. If I say SN1 point of view, SN1 means preparation of carbocation. So in this case, it will result in allylic carbocation. It is stabilized by the resonance. This double bond comes here and positive charge goes, and these two positive charge are exactly equal. That's why it is called as equivalent canonical form. Okay, means the carbocation is extremely stable, so SN1 happened efficiently. Very good. Fine. Now SN2, if I say, if you look at this center, it is actually a primary carbon center. So primary carbon chloride bond. So obviously SN2 is possible because it is less bulky. So this is the overall explanation. So first of all, carbocation stability, so SN1 preferred, less bulky, so SN2 preferred. That's why these compound C undergoes both SN1 and SN2 more efficiently. By the way, student, based on my knowledge, there are three molecules. This is one is this allyl chloride, second is this methoxy methyl chloride, or it is sometime it is called as mom chloride, in short methoxy methyl chloride, mom chloride, or another substance that is benzyl chloride. So these three substrates, student, shows both SN1 and SN2 efficiently. I made a dedicated video on this topic. I shall share the link in the description box as well as I button. Please visit. It's very interesting to learn. Now, in this discussion, what is the answer of today's question? Question number 3. So these allyl chloride reacts efficiently for both SN1 and SN2, and in this case, what is the product? Obviously, the product is allyl alcohol. By the way, student, and additionally one explanation I want to give about this molecule, which is MO explanation. What do I mean? So we know in SN2 reaction, the transition state has a p orbital. I mean, you can say it's a trigonal bipyramidal transition state TBP, where p orbital's one lobe is attached to this chlorine leaving group and another lobe is attached to the nucleophile, and in this case that is obviously hydroxyl anion OH minus. So these transition state actually are negatively charged. You can consider electron rich. Okay, so this electron rich transition state, and this transition state is stabilized by the conjugation of these alkene. How? So this is one pi bond, this is one pi bond. So this made the alkene. Now if you look at the pi star, the symmetry is this: plus, minus, minus, plus. So symmetry is this. Here also you can say plus, minus. Actually symmetry is an arbitrary choice to explain the phenomena. Now these can participate in conjugation with this pi star. I mean the extra electron density in this p orbital, it is actually 3 center 4 electron bond. So the extra electron density in this p orbital in the transition state is delocalized to some extent in the pi star of this carbon-carbon double bond or pi bond. Consequently, the TS energy is reduced, and if the energy of the TS is reduced, since SN2 reaction is actually a one-step reaction, so you can expect the energy of activation also reduce. So if energy of activation reduces, rate of the reaction enhances. Consequently, these allyl chloride shows very good reactivity for both SN1 and SN2. So this is the SN2 reactivity explanation on MO concept. Please try to remember, it's very important. So this is the overall discussion. I think this video may be useful. Thanks for watching. See you in my next video. Bye bye.